org2b. Today is Thursday, January 19th. Kind of half and half. Fixed test day as well as 6 pages day. So here's what I want to add on here. Okay, so step 1, I asked them to go down for me. All right. All right. I asked them to put standard 1 at the top of this one, just in case at some point. Let's see. It's doing that right, which I don't like, but whatever. Standard 1. Mine is in here like that. Wherever you put yours, hopefully it fit properly. If this is going to be one of your 6 pages, I don't know that we finished D and H. If anything, F and B, I think weren't finished. So if you choose this to be yours, for sure you want to kind of get those pieces in. This is a good choice. But let me actually add this bottom section to the whole bottom part. Isn't done, and I don't want to spend too much time today because for the people who have sections to address, plus 6 pages. I don't know where you fall in all that. We're going to try and maximize the time, so let's see if I can get down to the bottom section. Calculators out there, I put like half and half, but I think there's enough for everybody. Anybody not have a calculator right now? Oh, all right. So here it comes. Here it comes. This little section, these 3 little problems here, we didn't talk about it much, so I'm just going to go straight at it. Please circle the word reference. Reference angle, please. Reference angle, you're going to put between. Okay. Yeah, that's better. Between 0 degrees and 90. Alright, in that case, you can just kind of watch it, but yours is that, that's fine. In this little section, here's the deal. Whatever angle they give you, you need to reduce it. And I hate to use the word reduce, to think of fractions, but it needs to be rewritten as an angle that's between 0 and 90 degrees. Well, what does that mean? How do you do that then? If the angle they give you is bigger than 180, you're going to do 360 minus that angle. Voila, you win the game. If the angle they give you is less than 180, you do 180 minus the angle. Voila, you win the game. Now, because there are only 3 of them, once I do this first one, there's not a second version of that one. Once I do the set up the second one, technically you only have one that you're doing kind of on your own. So here's what I mean. Because this number here is less than 180, I just go 180 minus that degree, and the answer is the reference angle. Right? So pencil pen out to write on the calculator. Okay. With the B, because the angle is bigger than 180, you do 360. You do 360 minus the given angle, and now you have the reference angle. Please do the third one. Now you have those little pieces there. If ever you hear reference angle, one, it has to be an angle. Sometimes they call it acute. An acute angle just is, of course, between 0 and 90 degrees. The last one is bigger than 180, so you know you're going to subtract. Ooh, the last one might actually be a trick problem. We subtract that 360, I don't know what it comes up to. But if it's not between 0 and 90, then we have to do another move.
Yeah.
Oh. On C, you have to do 2 things. You have to do what you did in B first, then with that new number, then you have to do what you did in A second. So again, for number 1, straight subtraction, no big deal. For B, straight subtraction, no big deal. For C, you get a doubler. Alright, the other, let me give you like a minute or so to mess around with that. Famous angles on the bottom, so this sheet can go in. 90. 180. What's going down here at the bottom? Yeah, 270. Basically, it's your 9 timetables. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 270. And then, of course, here you can put the 360 and 0 degrees. This is if you want this to be one of your 6 pages. Here's how you find this thing out. To find out how much each slice of pie is, or the angle is, basically what you do is count the number of slices up to 180 and divide 180 by that number. In other words, how many slices are there to this pie going up to 180? There are 4. For those who don't see them, there's 1, there's 2, there's 3, there's 4. When you do the 180 divided by 4, it will tell you the degree of each of the slices. Someone on the calculator, please do 180 divided by 4. 45. What that tells me is this. Each one of these slices is a 45 degree. So for the first column, for the first coordinate that they're looking for, if I were writing it as a degree, I know this guy here is degrees. His friend here is, 45. Oops, sorry. I put that 90 and that 180 when they actually wanted it on the line. In other words, I put the 90 down below here, not recognizing that on the first version they want 90 degrees. That's what that little circle is there. What is this next thing going to be? Because all we have to do is add 45 to each one of them. So 90 plus 45 will get me the next guy in line. So if you can see here, this was 0 degrees. We added 45. From here we did 45 to get the 90. And again, it's the only thing we want to turn this one in. It's not very hard. It's just we didn't cover it. I think Jose said 135, and he is correct. And then you just wrap around, keep going around the circle that way. Adding.
Is that 135?
Adding 45 every time you go around, and that is 135. So let me give you a minute to add in and fill in all of the degrees going all the way around. Again, I put this 180 here when really they want it there. The last piece of this puzzle, even as some of you are still adding, notice they have pi right next to it. Basically, they want you to find the radian measure of it. In other words, I happen to know, and again, you could probably use your yellow sheet for this, even though I know they probably want you to calculate like you did there, but for this day, I'm going to have you just go to yellow sheet, and that is, anybody know what the radian version is of 90 degrees?
Half.
So they put this pi on the side. I almost wish they would have, normally it's written, I'll write it both ways so you can decide how you write it. 1/2 pi is 90 degrees, but normally we write it as pi over 2. 45 degrees, you have to do it like you did up there. You have to just do the 45. And someone did something interesting. When they did this plus sign, they kind of put some things out of order, and I'm trying to see if there's one on here. I'll do it with the radian. They're supposed to change. I'll do it up here. They're supposed to change this into degrees. For some reason, when they did their plus sign, they put the 6 up here somehow. That was on the bottom to begin with. Just a reminder, just in case it was you or if you did something like that, keep your 6 down there, and of course you'll do your 180 over pi. And then of course you do top times top, bottom times bottom. Just in case, I can't remember what paper I saw that on, but I saw it somewhere. In any case, let me see if I can get this down here. Some of you, when it's time to do your 6 pages, is when you'll do this. So I'm just putting it now because really the main part is that sine wave scores and let people address standard 3 in particular. People who need to do standard 1 and 2, you can look up here to remind yourself how to do it. Standard 2, review on the yellow sheet to remember how to do it. And then standard 3 is the one where people need help. So again, if I do 45, I do try and turn it into radians, pi over 180. I think somebody maybe forgot it. Just a reminder, it really is just a problem where you reduce the fraction. Somebody didn't, I can't remember who didn't go all the way down to the end. I can't remember if I marked it or didn't mark it, but I probably should have marked it in the case it didn't go all the way down to the end. Yes, I know 45 over 180 might be tricky to reduce. Anybody know what number goes into 45 and 180? 45 5 can. 5 goes into the top, what, 9 times? And into the bottom. Someone do 180 divided by 5.
36.
Now, with 9 over 36 do? Unfortunately not. Like, how do you know? Like, you gotta say, is there enough that goes into 9 and 36? 3 can, okay. There was a bigger number, but again, as long as you keep breaking it down, eventually you're gonna see that the top is a 3. 3 goes into 9 3 times, and into so here's what I would say for you as you're doing this one. If you just do the radians on the top, I'm going to accept that, because again, if you can do the 45, you can do the 135, clearly you can do whatever number this is that I'm not sure what number that is, and you can do this one. So in other words, what is Thomas saying to you? The bottom ones, you can write in the degrees, but you don't have to put in the radians for the bottom one. How many times 3 goes into 36? It goes in there 13? 12. Oh shoot, we can reduce it one last time. Yeah, which is why I guess it would have been good if we could have thought of the biggest number that goes into it. Alright, and the last time is going to be 1 pi over 4, which is just really pi over 4. So that was a long one just for that. Pause. Any questions about if you had to change the degree into radians, which is what we just did? Yeah. It's a standard one. Enough people, standard one worked out okay. Some people need to fix them, but it's easily fixed. All right, what does he want to give us too? So that way, while I'm calling out scores, if some people want to be working on this second sheet, they can be doing that as part of their 6. I want to give. All right, so again, another one that could be part of your 6. So this was straightforward. They give the example right at the top. This wasn't meant to be tricky. This was just meant to be like, okay, when I see pi, I know it means 3. So the top one, if the radius is 3, here comes the formula. This one I do want to write down the formula right next to mine, please. C equals 2. I wish I would do 2r times pi, but they do 2 pi r. Write that down next to mine so the big circumference isn't there. In this problem here, I do want you to please circle the 3. Just circle the 3 for me. And so once you do that, again, you can see the problem. We're going to put it in right below it. The 2, the pi doesn't change, and then, of course, the 3, which is the radius. So again, it's not supposed to be difficult. And then the last part is, because we're going to leave the answer in terms of pi, in other words, how many 3's go around this circle? In this case here, we just multiply the 2 times 3 to get 6. We're saying we have 6 pi's that go around that circle. In other words, if I go around the circle, 3. I'll do it this way. Do me a favor, with your pencil, go around here and write pi. We know the top half of a circle. On a unit circle, it's usually pi. And then the bottom half of a unit circle is usually pi. So normally, in a regular circle, you have 2 of these. You have the top and the bottom. It's 2 pi. On a unit circle is normally when it is a 1, if you put a 1 under there. Well, here's the deal. If on a unit circle, you usually have 2 pi to go all the way around the circle. If we were to multiply or triple the size of this circle, if we were to triple the size of this circle, which is essentially what we're doing, we wind up with not just 2 of those pi's, not just the top half and the bottom half, we wind up with actually 6 of those pi's. What I want you to kind of feel is, yeah, 6 pi is the answer. We get it. 2 times 3 is 6, 6 pi. We're like, what are you saying? We're saying if you had a regular size circle, and then you expanded it, whatever the amount was that you had on the regular one, it'll be expanded by the amount of the radius. So in this case, we tripled it. Look at problem number 2. Watch this. To get around a regular circle, you go 2 pi. Well, here's the deal. On number 2, not only are we going to expand it by 3, by 4, we're going to expand it by 8. So how many pi's will it actually be in this situation? I think it's going to be 16. In other words, you always start off with the standard 2 pi. That's how it all begins, the unit circle. Then, when they give us a new radius, they're saying, okay, we want you to expand it by that much. In other words, multiply it by that much. Instead of 2, we actually have 16 of those pi's. And pi is just 3. And again, as you go around, that's essentially what you're doing to all of them. But the idea is, next to each one, please do me a favor. Start off with 2 pi, so that you know how it begins, and then go to the rest. This will be another page that you get to use as one of your sixes. I'm going to give you just about 2 minutes.
Yeah.
All right, here we go. So again, if you don't need this one, be curious to the others and kind of let this one go. So here it comes. Step 1. And some people did this well. They put in their midline. They cut the top and the bottom in half. But again, if you didn't do that, that's step 1. Step 2, I saw the equations written. I have it memorized because I've been writing it so many times. Everybody know what the vector sign?
B, x minus h, plus
Yeah, after you write this thing so many times, it kind of gets stuck in your brain. I'm going to write down the cosine version of it as well. And in this one, you want to pay close attention to this one. So since you haven't done these, this is the one that most people have the trouble on. I'm doing cosine. The good news is cosine is written exactly the same way. And again, because we've written it so many times, it's stuck in my head. So again, if you look at your score, if the last number in your score is a 1, this is a section that you really want to pay attention to. If your 1 comes in 1 or 2, the other 2 pages, the yellow page is for standard 2. Some people, I think, just looked at it wrong or something. In any case, here we go. Step 1, you need to know, this problem is ugly. You need to know, how do I know where to start if it's a sign? The answer is this. Wherever the midline is, 68 in standard 3. So what you do is this. If it's going to be a sign, you put your dot right on the midline, and you start going uphill. Swing down, and technically that one come up again. So that's step 1 if you're going to do sign. Once you have that, now you're ready to go. Can someone say what the midline will be on this one? 37. It's right there waiting for you, looking for you. So everybody should have gotten the K. Now, some people on this one may have counted up 1, 2, 3 blocks. But for this particular problem, I'm going to use the numbers they have on there. Just the same way I think yours is going to have wacky numbers. The next one to get is usually the A. To find out A, it is the amplitude, how high you go from the midline to the highest point. To know that, you just take the 2 numbers. The highest point is a 71. The midline is a 37. And you subtract. Some numbers that were on there, they did some odd things to get their midline, their amplitude. Now, what's the amplitude on this one? You're going to be a 4. You're going to be a 3. So we got our 34. Take a look at it, see if anything's tricky. All right, here it comes. From there, everything in the middle.
Catch me outside. How about that?
Uh-oh, this one did get moved over. If it started right here on this line, then everything's fine. You don't need an H. You just do X minus 8. But in this case, it did get moved over. Where does it actually begin? It actually begins right here at the 3. That is the part that got some people. Take a look at the answer for sign and see if you're okay.
So H is where it starts.
H is where it begins, yes. Usually if it starts here, H would be a 0, or as you move along that line.
Okay, I get it now. I can do this.
All right, here it comes. The cosine. Cosine, everything is the same. The 34 is still there. The plus K,
Isn't it plus?
the K is still 34. 37.
See, now you feel me again.
No. Right. My bagel just went up to like 36. I know. Felt weird for just a second there. Like, oh, whatever. I think it's fine. All right.
I was like, Thomas. You make me.
All right. And Marcos, what did you say the H?
Look, I never turned this in.
Complicated.
Say.
All right, take a look at cosine and see if you're okay with it.
No, I'm not gonna fail that anymore. Last time I used it.
Yes.
No, it's not 69. It's the next.
Through my phone, and I'm like, are you?
Now I'm messing around with this one just because it looks uglier, even though they give you the
I'll do it.
the K.
Did I tell you that I already raced like 10 games a day?
Here it comes. Some of you already have this one, so I'm just gonna write it in. You just double check to see if it's what you need. Here it comes. CD. This is a sine. I think there might be something on your paper ready for this one, but I just want to write it in. What did we put for the let's see the cosine. What was the K on this one?
The K is 5.1.
Okay, thank you.
Yeah, I know what I'm doing.
What did we put for the A?
Rounding.
It's 9.9 here
Oh my god.
and a 5.1 here. What did we put? Or did we, I'm going to put a 4.8 even if we didn't have the 4, but for those who are like, okay, where's he getting the 4.8 from? Whatever your K is, the highest point.
Wait, what if you rounded it?
I would take, what'd you put? I put around 5. I'll take that. Would you have a 4? We took out the decimal. If you follow where I got the 4.8, then that's fine. If you can show the other numbers that you have, that'd be fine. And then, just hold this moment. That's why I didn't want to do it out of work. Because no, once we release in 2 minutes, then those who need to do whatever we want. All right, and so here comes the last part, of course. For the B, for sine, again, to know where sine begins, you find that point where it starts out like a roller coaster. Oh, shoot. What do we put for this? It's 6, 7, 8, 9. We put 9? Okay.
I was gonna put a plug in here now, but then since you did this, I was like, because I was like, I'm copying you.
Cosine. Two choice.
My question.
You can start here at the very beginning.
No, but I'm making this start low, so I was like,
Or you can start over here.
Watch me. I'm not gonna shut up with it. I'm always broken.
So for the first one, the KH.
Yeah, we can make this one noon or 11. In other words, it could be there, soft, but
If it has a smudge.
take a look at those two answers.